Convert sine of sine inverse x plus cos inverse y to an algebraic expression in terms of x and y when minus 1 is less than equal to x less than equal to 1 and minus 1 less than equal to y less than equal to plus. Look at the unit circle, that is radius is 1, drawn in the diagram with center at 0. The points A, B, C and D on the circle and on the x and y axis have coordinates of 1, 0, 0, 1, minus 1, 0 and 0, minus 1 respectively. This is the unit circle here, and this is the x-axis, this is the y-axis. The point A has the coordinate of 1 and 0. Point B has the coordinate 0 and 1. Point C has the coordinate of minus 1 and 0. And point D has a coordinate of 0 and minus 1. Okay. Now, let sine inverse x be alpha and cos inverse y be beta. Then, by definition of the inverse function in trigonometry, sine alpha is x and cos beta is y. It is specified that minus 1 is less than equal to x and x is less than equal to plus 1. Therefore, since sine alpha is equal to x, we have minus 1 less than equal to sine alpha and sine alpha is less than equal to plus 1, or minus pi by 2 less than equal to alpha less than equal to plus pi by 2, because sine minus pi by 2 is minus 1 and sine plus pi by 2 is plus 1. Between minus pi by 2 and plus pi by 2, that is in the first and fourth quarters, cos alpha is positive. Look at the diagram here. This is the first quadrant and this is the fourth quadrant, and the first quadrant is between 0 degree to minus pi by 2 and the fourth quadrant is between minus pi by 2 to 0 degree. So when we specify that alpha lies from minus pi by 2 to plus pi by 2, we are considering only first quadrant and fourth quadrant. In these two quadrants, as we have mentioned here, in the first quadrant all sine, cos, tan, everything is positive, and in the fourth quadrant only cosine is positive. Therefore, in these two quadrants, cosine is positive in both. So we conclude that cos alpha is positive. Since sin alpha is equal to s, cos alpha is equal to 1 plus x square. We take the positive sign before the square root sign because cos alpha has to be positive. Similarly, it is given that minus 1 is less than equal to y less than equal to plus 1. Because cos beta is equal to y, we can write that minus 1 is less than equal to cos beta, which is less than equal to plus 1. Or pi less than equal to beta less than equal to 0, because cos pi is minus 1 and cos 0 is plus 1. Between 0 degree and pi, that is in the first and second quadrants, sin beta is positive. That is from 0 to pi is from here to here. This covers the first quadrant and the second quadrant. In the first quadrant, all are positive. In the second quadrant, only sign is positive. Therefore, in these two quadrants, sign is always positive. So, between 0 and pi, sin beta is always positive. Because cos beta is equal to y, we have sin beta is equal to 1 plus 1 minus y square. We have put the positive sign here, that is to emphasize that sin beta is positive. Before going any further, please like, subscribe, share and hit the bell so that you can be immediately notified for new uploads. It's completely free and only takes a few seconds, and you can always unsubscribe later if you want to. Also, if you know about any interesting problem that you would like me to solve, please upload it in your comments. Without further ado, let's proceed with the rest of the video. So far, we have found out that sin alpha is x, cos alpha is positive sine of 1 minus x square root, sin beta is plus 1 minus y square root, and cos beta is equal to y. Therefore, sin alpha plus beta is equal to sin alpha multiplied by cos beta plus cos alpha multiplied by sin beta, which is x multiplied by y plus square root of 1 minus x square multiplied by square root of 1 minus y square. Now, sin of alpha plus beta is sin of sin inverse x plus cos inverse y. Therefore, the algebraic expression for sin of sin inverse x plus cos inverse y is x multiplied by y plus 1 minus x square multiplied by 1 minus y square, and this is in terms of x and y. This is the required answer. Thank you.